Okay, instead of being given the normal to the required plane directly, it can also be provided indirectly like two vectors that are parallel to the required plane. So let me take the plane like this and let I have two vectors like this. Say this is u and this is v. I have two vectors provided on the plane and also one point on the plane. Let it be the same that the coordinates x naught, y naught, z naught. And to find the equation of this plane, I am now going to take some arbitrary point P on the plane and let it have coordinates as usual like x, y, z. But now you are given only two parallel vectors. So how are we going to make use of these two parallel vectors to find the vector normal to the required plane? The student should recollect that if two vectors, let the components be u1i plus u2j plus u3k and v vector being v1i plus v2j plus v3k be given, then we know that the cross product of u and v will be a vector perpendicular to both u and v, consequently perpendicular to the plane. That is what we are going to use now. So given the two vectors u1i plus u2j plus u3k, v1i plus v2j plus v3k, to get the cross product of that, of course we know that we have to put it in determinant as ijk determinant u1, u2, u3 and v1, v2, v3. This is going to be opened as I times u2, v3 minus u3, v2 minus j times u1 v3 minus u3 v1 plus k times u1 v2 minus u2 v1. Now this is going to act as the normal vector. So let me now assume that the components for the normal vector along the ijk directions are ABC, where A is going to be this one u2 v3 minus u3 v2 and B is going to be u1 v3 minus u3 v1 and C is going to be u1 v2 minus u2 v1. Now I can plug it in the equation that we previously derived, that is A times x minus x naught plus B times y minus y naught plus C times z minus z naught equal to 0. As I have told you, A, B, C will be these. That is, this is A, this is B, and this is C. So plugging in those values, and when you have the numerical components, it will not be very tough to handle it. It will be only some numerical value that we will be getting here. So put it in the place of A, B, C. And for x naught, y naught, z naught, of course, will be given a point. Therefore, even if you are given two parallel vectors, that is two parallel vectors to the plane, we can get the cross product of it to get the normal to the required plane and use this point, and the same thing continues as A times x minus x naught plus B times y minus y naught plus C times z minus z naught equal to 0 is going to be the equation of the required plane.